Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aisha Amira binti Mat Isa and my record number is CF200029. So here our slide presentation for the project MFA 10203 Advanced Structural Analysis. Alright, so firstly is executive summary. Our project we involve by utilize that Pro software to conduct structural analysis simulations on a specific 2D mine steel frame. So they have two. Based on this project, we use column and roof members. According to the British standard, we use for the column is a UC 254 times 254 times 733. And for the roof members, we use UB 203 times 133 times 25. So next, here is our company profile. That name Azra Consult with a slogan Innovate, Build and Inspire. So basically, Azra Consult is a dynamic engineering consultancy company dedicated to the delivering innovative solutions that redefine the landscape of construction and engineering projects. Established with a commitment to excellence, we pride ourselves on being at the forefront of innovation, fostering sustainable practices and inspiring breakthroughs in the industry. Okay, so right here is my team members. The first one is me, Nur Aisha Amira binti Mat Isa, as a senior consultant manager. The second one is the Rohadatul Aisha binti Maleh as a quantity surveyor. The third one is Muhammad Alif Aimran bin Jamari as a civil and structure engineer. And the last one is Zafri bin Ayub as an infrastructure engineer.
Hi, Assalamualaikum. My name is Zafri bin Ayub. My matric card number is CF20071. And I want to present about the project briefing. For the project briefing, the primary objective of conducting frame analysis in this project is to facilitate the construction proposal for a luxury car warehouse. This warehouse is located in Tanjung Lebong, Langkawi. Okay, this is our proposed location at Tanjung Lebong, Langkawi. Design for parameter for this project. The design would life is using 50 years. For the exposure condition is using XC3, which is moderate humidity concrete inside building with moderate or high air humidity external concrete sheltered from rain. The rest is the fire resistant, yield strength, ultimate strength, and modulus of elasticity. For the actions, okay, this is the dead load, which is sulfate of roof construction, zinc roofing, service, sulfate of purlin, and steelworks. For the life load, variable actions, the imposed load is 0.75 kilonewton per meter square. For the wind load, we are using 2.124 kilonewton.
Alright, in this project, we need to model the frame structure in order to analyze it. So the loading calculation is required. First, we go to the loading on truss and frame, which have the loading of dead load and live load. On truss, the total dead load that have in each purlins is 13.5 kN, and the total live load in each purlin is 2.6 kN. Then, all the loading on trusses will be distributed to frame, which give value combination loading in UDL is 11.6 kN per meter.
Assalamualaikum, and my name is Muhammad Alif Imran, CF200246. So I will continue to present for the software part. So we use StepPro to design the simple 2D frame. So first of all, what we need to do is we have to insert all the coordinate in order to get this simple 2D frame. So for the roof member, we use size universal beam 203 multiplied by 133 multiplied by 25. And for the column, we use universal column 254 multiplied by 254 multiplied by 73. So both of these size is based on the British standard table size that provided in the software. And for the material, we use steel 275 Newton per millimeter square, which is mute steel. And for the supports, we use a fixed end for both column. So as you can see here is the fixed end support. And for the loading, so this loading we determine based on the manual calculations we made so far. So as you can see here, we can go to the structure diagram in order to see the loads. So here is the dead load, which is at the middle is 13.5, and at the edge of this frame, negative and 6.75, and for the live load is at the middle is 2.6, and at the edge is 1.3, and for the for the wind load is 22.124 kilonewton. So all this value is determined according to the standards Euro codes and the manual calculation. And if we have insert all the data that required, so we can go to the analysis to run the analysis. So here we choose still. So make sure for the current code is BS59502000. So once this code has been changed, we go to the run analysis. So as you can see, there is no error and no warning, means that the loading applied for this frame is acceptable with the size that provided. So once we have run the analysis, we go to the post processing to see the behavior of these frames. So here there is a load, which is the function is to select which behavior we want to see. So there is a dead load, live load, and the combination load. However, for this video, I will see the behavior of the maximum combination load. So this is the displacement of these 2D frames. So if you want to see the value of this displacement, we always can go to the annotate and select the resultant. So this is the maximum value of displacement of these 2D frames. So next we will see the axial force in x-axis. So this is the behavior of axial force that the loading that we apply for these frames. So if you want to see, so we go to the annotate and select the edges. So this is the value of the axial force. So we can always scale the size of this axial force, and this is the shear force of shear force in the y-axis. So this is the behavior of shear force of this simple 2D frames. Same, if you want to see the value, we go to the shear and we can select either we want to see the value and maximum and midpoint. However, I will see the maximum value of this behavior. So this is the maximum value of shear force for these 2D frames. So next we will see the bending moment diagram. So this is the bending moment diagram, the behavior of these frames. So we just go to the bending and see the value. So as stated here is the maximum value of the bending moment diagram. So we can always check the value over here where it's recorded all the value of the axial force, shear force, and the bending moment diagram, as well as the displacement. So I think that's all from me for the software analysis part. Thank you very much.
We will use and consider the method of plastic analysis. So we will calculate the three type of cases, which is first the beam mechanism, which give value of MP is 44.24 kNm. Then second is sway mechanism, which give value of MP is 1.59 kNm. And also the last one is the case of combined mechanism, which we got the value of 30.5956 kNm. On this discussion, I will compare the result of the manual calculation and the software calculation. So first, as you can see right here in this slide, for the reaction, the software analysis for member 1 and 8 shows the greater value than manual calculations. This is maybe due to the application of loading is different in both analysis, where the manual calculation is using combination action is 1.35 GK plus 1.5 QK, while the software have its own setting different. However, the value of reaction is almost close for both analysis, so we can assume that the analysis of both analysis got almost the same value. Alright, for the shear force, the value in software analysis is greater than manual calculation. This is due to the software analysis consider the safety of structure, thus give the greater value of shear force. The greater value of shear force later will affect the choose of structure size. So on the member 8, the value for manual calculation is 0, as no consideration of vertical loading on this member, thus the result gives the 0 answer. And the last but not least, the value of bending moment shows the manual calculation in member 2 is greater than the software analysis. This is due to the in manual calculation, we use and consider the plastic analysis method, thus give the greater value of moment on member 2. Now we come to the conclusion. The successful analysis of the 2D frame for the luxury car warehouse achieved through a combination of StatPro software and manual calculation. This combined approach not only ensure accuracy in the analysis, but also foster a reliable structural design for the luxury car warehouse. The successful outcome of this analysis highlight the importance of the balanced and integrated approach in structural engineering.